on the screen chemistry reference sheet, copyright from the California Department of Education, that you use on pretty much a daily basis. And it's called the periodic table of elements. Okay, it's not just called the table of the elements, but it's known as the periodic table of the elements. Have you ever wondered why that's the case? Why is it called periodic? What does that mean? What does periodic mean? Well, periodic means that something happens periodically, over and over and over again. So the title of the table of elements, the periodic table of the elements, comes from the fact that we find patterns that reoccur in this table over and over and over again. We did an activity in class that asked you to identify some patterns that we see in the periodic table. And they're in your lab notebook, and we will talk about, I'll go over that list exhaustively with you. One of the things that we find is that as we go across each period, the same thing happens in terms of, they represented it in terms of the size or diameter of the circle. Okay, so if you recall, you guys, what happened to that circle as we go across? What happened to that circle as we went down? And the same thing happened whether we're going down this column or group or family, or this one, or this one, or this one. Okay, the same pattern over and over and over. It's periodic. Alright, so what we're going to look at today, guys, are those patterns. Well, we're going to begin to look at them. There's a few that we're going to look at extensively. And today it is the radius of an atom. Now, you can also think of it as the diameter, right? The volume of an atom. Okay, but for whatever reason we focus on radius. Okay, so what happens to the volume? Okay, the actual diameter of the thing, or the radius of an atom, as we go across a period. Well, if you recall, atomic radii usually decreases as we go from left to right across the periodic table, as long as we're staying in the same period, in the same row. So what I mean here is that as we go from left to right, the radius of the atom gets smaller and smaller and smaller. The radius of the atom gets smaller and smaller and smaller. Now this might be a little bit counterintuitive, because as we go from left to right, what happens to the number of protons and electrons that are being, well, what's happening to the number of protons and electrons as we go from left to right? We are increasing in number. So it would seem that shouldn't be the case, right? Shouldn't they be getting larger? But in fact, you guys, the diameter, the radius of the atoms is getting smaller and smaller and smaller, so that by the time we're at the end of period 2 at neon has got the smallest radius of all of the elements in period 2. Argon has the smallest radius of all of the elements in period 3. Well, why is that the case? As the effective nuclear charge increases, it attracts the electrons more strongly. So what we get, you guys, as we are going from left to right, is we are getting a greater effective nuclear charge. Okay, so from where does this nuclear charge arise? Well, we're talking about the charge of the protons that are in the nucleus. So those protons are positively charged, and so that positively charged nucleus pulls on the electrons. And as we get further and further to the right in a period, we're adding more and more protons to the nucleus, and so that nucleus is attracting its electrons more and more strongly. So it's pulling them in tighter and tighter and tighter. Okay, but then what happens? The nucleus gets, the radius gets smaller, 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 smaller. And then, when we start here at period 3, what happens to the radius? Well, suddenly it becomes what? It becomes real big again. Okay, so as we go down a group, what happens to the radius of the atoms, of the elements? They get bigger. So radii increases as we go down through a group. So from top to bottom, and it doesn't matter what group or column or family we're talking about. Small, larger, 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 larger. Small, large, larger, 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 larger. Okay, it's periodic. It happens in this one, it happens in this one. This is a repeating pattern. Here, here. Small, large. Okay, so why is that the case? Because you think, okay, we get effective nuclear charge getting greater and greater and greater, and then suddenly here at the end of period 2, it's about as small as it's going to get, and then we get down here to period 3, and things get larger again. And they get even more large, more large, more large. Okay, why is that the case? You probably have a pretty good idea in your mind right now. As we go down a group, electrons exist in quantum levels further and further from the nucleus. So of course, as we're going down the group, electrons are inhabiting quantum levels ever further from the nucleus, right? Increasing the radius. So here we have electrons in quantum level 1. Here, the valence electrons are in quantum level 2, further from the nucleus, right? So they're just the volume of the atom, the radius of the atom just gets ever increasingly larger because electrons are inhabiting quantum levels that are further and further from the nucleus. Okay. Whereas, you guys, when we're talking about this, where are all of the electrons, the valence electrons, in these elements? They're all residing in quantum level 2. Okay, so they are not getting added to shells or quantum levels further, not shells, quantum levels further and further from the nucleus. So electrons are being added to the same quantum level, but because the nuclear charge is getting greater and greater as we go across, of course they can just pull those things in tighter. And here, yeah, sure, we're adding more nuclear charge, but in terms of effective nuclear charge, you guys, it's not as much. Why is that the case? Because the electrons now, when we go here, yeah, we've got lots of protons, but our valence electron is where now? It's in a quantum level 3, further from the nucleus. So even though this has a greater nuclear charge than this, effectively it can't pull that quantum level 3 electron any closer. So when we're talking about this increase in size, you guys, that is because the electrons just continue to exist in quantum levels further and further from the nucleus. Okay. Positively charged ions have a smaller radius than the neutral atom because of an increase in effective nuclear charge. Okay, so if we think about positively charged electrons, positively charged ions. In order to become a positively charged ion, what does the atom do? Lose or gain electrons? It loses electrons, right? So now you've got fewer electrons than you have protons. And that nuclear charge, that effective nuclear charge, can pull on the remaining electrons more because it's distributing its force to less electrons, making the effective force on each electron more. That was wordy, huh? So, meaning that here we've got the same number of protons in the positively charged ion, but they're pulling on less electrons, right? So a potassium atom has 19 protons and 19 electrons. A potassium ion has 19 protons. This is where the nuclear charge is coming from, right? The number of protons. But now there's only 18 electrons there. And so that same amount of charge is being applied to fewer electrons, so it's going to be greater on each of those electrons than it was before. It's being distributed to 18 electrons as opposed to 19. And so we can just pull them in. It can attract them even more tightly. So then what's going to happen with negatively charged ions? It's just the opposite. Negatively charged ions have a larger radius than the neutral atom because of a decrease in the effective nuclear charge. So in this case, the same number of protons are pulling on more electrons. So my example here is the chlorine atom and a chloride ion. Chlorine atom has 17 protons, 17 electrons. Chloride ion, okay, because it's got a -1 charge, that means it's got one more electron. And so those 17 protons, those 17 positively charged protons are now having to pull on one more, exert force on one more electron. And so it's going to be distributed to a greater number of electrons, therefore it will be a lesser force. And so it won't pull them in as tightly, won't attract them as tightly. And so the radius of the negatively charged ion is going to be greater than the neutral atom. Okay, you guys, effective nuclear charge is our key term here. And that comes from positively charged protons in the nucleus attracting the negatively charged electrons. Okay. Effective nuclear charge. Trends in radii. As you go from left to right in a period, atomic radii gets smaller. As you go from top to bottom, atomic